In this video, we are going to learn how to find the greatest common factor between two algebraic expressions. I'm going to go over why the process works, as well as go over 3 examples utilizing this process so you're in great shape. Let's dive right into this. The first problem we're asked, as we're asked in the other 2 problems, to find the GCF between 4 times x squared times y and 6 times x times y cubed. Each of these are individual terms, and if we recall from previous videos, that means that this term is joined all by multiplication, as I spoke out, as well as this is. So 4 times x squared times y, 6 times x times y cubed. Now the process is not so bad. You first start out by figuring out what is the greatest common factor between the 2 coefficients. And again, the greatest common factor is the highest number and the highest power, right, of the variables that goes into each term. So if we look between 4 and 6, what is the largest number that goes in between 4 and 6 or goes into 4 and 6? 2. So 2 is the GCF of the coefficients. So I kind of just start out with that. Then I'm looking for the greatest common factor between the x terms because each of those are very clearly like terms and thus share some kind of common factors. So here we've got 2 x's in there, and here we have 1 x. So the greatest number of x's that is a part of each of those terms would be one of them. There's 1 x in here, though there's 2 in here, there's 1 in common to both of them. So it'd be 2 times x. And then finally, you look at the y values. There's 1 power of y here, and there's 3 y's there, y times y times y. So what is the greatest number of y's in common to both expressions? 1, because there's 1 in this one. So your greatest common factor is 2 times x times y, or 2xy. Again, the process is find the greatest common factor of the coefficients, and then basically you're finding the least power of each of the common variables, because that would be the most number of times that that variable goes into each term. Now let me go over why this works. So if we expand each of these out, we see that 4 can be written as 2 times 2 as a prime factorization times x, x squared, times y. And then 6xy cubed can be written as 2 times 3 times only 1x times and then 3 y values, y times y times y. We see that in common you've got a 2 and a 2, and then we've got only 1x in common. That's the lowest power, right, the least power that is in each of these expressions. And then the y's, there's only 1 in common to both of those. Again, the least power there. And that is why you find the least power of the variables to add on to your already good knowledge of finding the GCF of the coefficients. That's all. That's the why. So let's practice this skill 2 more times just to nail it home in case that first example left you feeling like, I don't know, I gotta see some more. Let's do it. So right behind me, right over here, I've got 7a cubed b squared and 21a squared b to the 5th. So the greatest common factor between 7 and 21, what's the highest number that goes into both of them? 7. 7 divides into itself and into 21 evenly. So we've got our coefficient nailed down. Now let's look at the a values. You have 3 a's being multiplied, right? A times a times a, and here a squared, a times a. So the least power that is in common in both of these is a squared, or 2 a's in each of them. Finally, you've got 2 b's, b squared, and 5 b's, 1, 2, 3, 4, 5, being multiplied by themselves in the second term. So the greatest common factor in terms of the b's, 2 b's. b squared is the lowest number that is in both of them and thus in common. And that's your GCF for number 2. Sweet. Finally, number 3, you've got m times n to the 4th and 6m squared times n cubed. I wanted to give you a problem where we didn't have a coefficient that is explicitly out there. So what does that mean? Well, it means the coefficient here is technically 1. What's the greatest common factor between 1 and 6? 1. 1 is the greatest common factor. So we really don't have anything greater than 1 there as far as the coefficients go. We look at the m values. The highest power of m in each of these is just one of them. And then we look at the n values. There's 4 n's being multiplied here, 3 n's there. So the greatest number of n's between both problems in common would be n cubed. So we'd simplify that down. 1 times anything is that anything is itself. And so that right there, m times n cubed, is your GCF. That's it, folks. How to find the greatest common factor when variables are involved. This skill is going to be helpful as you go later on in an Algebra 1 course, and you might even be watching this as part of your Algebra 1 course just to review this skill set. See you in the next video.